Hi everyone, welcome to our first live group tutorial brought to you as part of the MyTutor online school, and thank you for joining us. Today's session is on solving quadratic equations, and it's going to be led by one of our star tutors, Molly, who is a student at Bath University and has completed over 150 lessons with us. So what we'll do is I'll hand you guys over to Molly, who will be leading the session now.
Okay, hopefully you can all hear me. Hiya, I'm Molly, second year maths student at the University of Bath. So today we're going to be going over how to solve quadratic equations. Feel free to shoot any questions or anything. You can take notes, not take notes, just listen, whatever you want to do. So I'm just going to get the lesson space set up and then share my screen, so hopefully you can see it. Wants to work. Camera. Okay, perfect. So hopefully now you can see my screen. So we're going to go through several things today. Please let me know if the pace is too fast, too slow. This is an experiment for everyone. So quadratic equations are basically solving anything with an x squared in it. And the thing about this is that there are always going to be two solutions, unless it's something squared. So I'll explain what I mean by that. Because a quadratic curve looks like this, the solutions we can think of as the roots of the equation are going to be on the x-axis. So there's going to be two solutions. There could, if it just touches it at one point like this, there could just be one solution. Or if the curve doesn't cross the x-axis like this, there could be no solutions. So don't worry if you don't understand that. We're going to think about it throughout graphically and algebraically, because some people's brains work with graphs, some people's brains work with algebra. So that's what we'll go through. So we'll start by doing some basic ones just to explain what I mean. So for example, a really simple example would be x squared equals 9. So for this, the immediate thing that you might think that this is 3, which is correct, but it will actually be plus or minus 3, because 3 squared is 9 and minus 3 is 9. And again, if we want to think about this graphically, we've got our x squared curve, so I can draw that here. And then when we say equals 9, that means basically where it intersects with the line, y equals 9. So where it intersects here. And then we can see our two solutions here, minus 3 and positive 3. So hopefully that makes sense. The basic thing to remember is that if you're square rooting something, it's plus or minus. So we can then get slightly more complicated ones. For example, 3x squared equals 48. So this we've got to do a little bit of fiddling before we can do that. Oh, someone says, how long will this be? An hour, so until 2. So 3x squared equals 48. So we want to get the x squared term by itself. So we're going to divide both sides by 3. So we end up with x squared equals 16. 48 divided by 3. So then x equals plus or minus 4. So again, it's like that. It's like this, but with this line being a bit higher. So where it equals 16, we have it here. Okie doke. Let's have a look at one more example where we've got to do a little bit of extra work. So 5x squared plus 2 equals 135. So this one looks a lot scarier, but again, don't panic. Get it to a situation where we just have x squared on the left-hand side and we know what we can do with that. So the first thing that we can do, someone said, is this happening every day? I don't know yet. Maybe. I'm not sure. But yeah, you'll be informed via email. So 5 lots of x squared plus 2 equals 135. So the first thing that we'll do is divide both sides by 5. So because this whole bit is multiplied by 5, we'll get rid of that 5 and then divide 135 by 5, which will give us 27. And then we can just subtract the 2 from both sides. That's how we get x squared on its own here. So x squared equals 25. So then x will be plus or minus 5. So there are some like that, as I said, that involve a little bit extra work. But it's just kind of fiddling about with the algebra and getting it so that you have the x squared on one side and whatever you want on the other side. So one thing that this introduces actually, which I'll just go over briefly, is expanding out brackets. So sometimes you need to expand out brackets as part of a question. So although that's not the actual solving part, sometimes you need it as part of it. So apparently stuff is happening in the chat. Oh, we'll be answering questions at the end. Oh, okay, gosh, there's lots happening in the chat. I don't know how this works. So someone said, why does x squared equal 16 on that one? Gosh, I should have seen that when I was doing that one. Yeah, okay, I'll keep in mind all of the questions. And yeah, like Frederica said, we'll do them at the end. But yeah, keep them coming. That's good. Cool. So I'll talk very briefly about expanding brackets because, like I said, it is a part. So when we expand brackets like we just had there, so such as 5 lots of x squared plus 2, another thing that we could have done, rather than dividing by 5 first, is we could have expanded out the brackets. So what this means is that we take what's here and we multiply everything by it. So we'll do 5 times x squared, 5x squared, and then it will be 5 times plus 2, which is plus 10. So 5 lots of x squared plus 2 is the same thing as 5x squared plus 10. Now this gets a little bit harder when we've got an x in kind of like an x plus something in both of the brackets. For example, x plus 1, x plus 3. And what we have to do here, you might have heard of it before, is called the FOIL method. So the reason that it's this is because this is first, so we take the first 2 and multiply those together, x squared. Then it's the outer, so we take the outer 2 and multiply those together. So this is x and 3, so that's just 3x. Then it's inner, so these 2 here, x and 1, so that's just plus 1x or plus x. And then finally, last, so the last 2 in the brackets, 1 and 3, so that's plus 3. And then we can simplify this by combining these x's here. 3x plus x is 4x, so we get x squared plus 4x plus 3. So that's something that you've probably seen before, but it does come in useful whenever you're talking about quadratics. And factorizing, which we'll cover in a moment, is the opposite of this. So it's going from this to this. So understanding this way helps you to understand the other way. So we'll do a couple more examples. I'm going to be covering tons and tons of examples. So hopefully, even if the explanation bit is a bit confusing, through the examples, it should make a lot more sense. So let's go through a couple more expansions just to get to grips with that. So let's say we have x minus 5, x plus 7. So this one, we've got a minus, so we've got to be real careful with that. So we'll do the same thing again. We'll do this FOIL method. So first, x times x, x squared. O, outer, x times 7 plus 7x. Inner, now this is minus 5 times x. So this is a minus 5x. And then finally last, minus 5 times plus 7. So that's minus 35. And again, we can combine the x's. You'll see this really common pattern. You're always going to have an x squared, 2x terms, and a constant. So sometimes, you know, if you do this a lot and get really good at this, then you can write this straight down without doing that step, because in your head you go plus 7x minus 5x. So there, all we've done is 7x minus 5x equals 2x. Okay, Duke. What about x minus 3, x minus 5? I'll give you a little minute to think about it. I'm just going to check the chat in case there's any questions that I need to answer now. Could you go a bit slower? Yes. Okay, I'm glad I checked the chat. Sorry. Why don't we expand the bracket first on the third question? Okay, that is because we definitely could. Let me just go back to that. Can you do the grid method? Yes, I can explain what that is as well. This is essentially the grid method without drawing the grid. The reason that we don't expand the bracket, gosh, I don't know where that question's gone. This one, we totally could expand the bracket first. And that would give us this, so 5x squared plus 10 equals 125. And then you just do the subtraction and the division. It just does it in a different order. So we can do either there. The grid method, I'll show you what that is, because that can help some people. I'll in fact go through this question with the grid method, or at least what I assume the grid method is. So I believe it's where we're going to write each of these out. So x and minus 3. And then here we have x and minus 5. So these are all the things. This is basically to make sure that we multiply everything by everything else. So this is why it's called a grid method, because you make a funky little grid like this. And then in each box here, you do what the multiplication is. So in this box, it's x and x. So that's an x squared. In this box, it's x and minus 3. So multiply them together, minus 3x. In this box, it's x and minus 5. So minus 5x. And in this box, it's minus 3 and minus 5. So this one's a bit tricky. Minus 3 times minus 5. When we multiply two negatives, they cancel out and they make a positive. So minus 3 times minus 5 is actually positive 15. And then the grid method, you just whack everything together that's in that grid. So you add it all. So x squared minus 3x minus 5x plus 15. Smush it all into one. And then again, we can simplify this. So minus 3x minus 5x. This can be a bit confusing as well. I still think of it for negative numbers on a number line. So if we imagine that 0 is here, and we're essentially doing minus 3 minus 5. So we go to where minus 3 is, and we know that minus 5 jumps us down 5 steps. So it's going to be minus 8. Okay, there's a lot happening on the chat. Let me have a look. Is the answer to this x squared plus 8x plus 5? Really close. It's minus 8x because you have to subtract the minus 3x and the minus 5x. Are you going to be moving on to more challenging questions? Yes. It's really difficult because obviously there's so many of you. I don't know what level to aim it at, but yeah, I will do. There'll be a lot. I haven't seen this method before. Well, hopefully it helps. Might use that from now on. FOIL doesn't have to be in order because addition can be in any order. So 2 plus 3 is the same as 3 plus 2. So FOIL can be in any order. I just always do FOIL because then I know I haven't missed any terms. I know that I'm doing first, outer, inner, last. Yeah, and that means that normally like the conventional way to write it is an x squared and then the x and then the constant term.
Hey Molly, it's Frederica. Just to say, I'll help you make sense of the questions if that would be helpful.
Okay.
But also to say to everyone listening, if you could also just comment in the chat with your level, that would be really good for further ones to give us a bit of a gauge as to who's on what level, and then we can help cater for you guys in that way. Thanks.
Cool. Thank you, Frederica. So yeah, I think like some of the questions I can leave to the end, but I think some is good to answer now. So level, I guess, like what year are you in? What grade are you working at? Pretty much. Cool, year 10, starting GCSE, grade 7, year 9, 7, A-level, year 10, grade 8. Okay, so there are quite a few, okay, 11 foundation level. Okay, so there's quite a lot of year 8 right up to year 11. Someone said instead of FOIL, can you do substitution? I don't really know what that is, but I can come back to it at the end. Okay, cool. So hopefully for those of you doing foundation, just let me know if this is the right level. I will be moving on to harder stuff to help those people who are aiming for higher grades, especially like year 11 doing higher. So yeah, cool. I'll kind of keep going the way that I have it planned because I think that should make sense. So we'll move on now. Hopefully expansion shouldn't come up too much in this. Obviously it's still great to be able to do, but today we're going to be focusing more on factorizing and actually solving the equations. Hopefully, yeah, the people doing foundation or like year 8, has this made sense? Because this is kind of my lower level stuff. Yes? Okay, perfect. That's good. That's reassuring. Brilliant. Yeah, hopefully I'll try to keep it at an understandable level. Cool. So now we're going to go on to factorizing quadratics. So this is the horrible part that everybody hates. I hated it when I did it. But once you make sense of it, it is totally fine. So as I said before, factorizing is the opposite of expanding. So it's taking something x squared plus something and factorizing it into brackets. And this is super useful because it means that we can solve equations. That's the point of why we do it. We're not just doing it because we can. We're doing it because it helps us with something, which will become clearer when we go on to solving them. So we'll start with the easiest type, which is when you have 2 additions. So obviously we've got several different types. This can be a plus or a minus. This can be a plus or a minus. So when they're both positive, we know that we can set up the brackets with 2 positives. And the reason is because the numbers here we're looking for to multiply to make 6 and to add to make 5. And because they're multiplying to make a positive and adding to make a positive, they themselves have to be positive. The reason we set it up with x plus and x plus is so that we get this x squared term. We know that that's going to come from our x's, so that's how we're going to be setting it up. So what I always do to start is you set up the brackets, you set up the signs that you're doing, because then all you've got to do is fill in the numbers. And then that's super nice. The video's big and the screen's into the lower right. Do you know how I can fix this?
I think I've just fixed that, Molly.
Oh, okay, perfect, thanks.
No worries.
I was going to say, I know nothing about Zoom.
No worries.
Okay, cool. Yes, someone just put the right answer on there. Congrats. Yeah, well done. So for those of you maybe didn't get that, what we do is we look at what multiplies to make 6. So we've got 1 times 6, we've got 2 times 3. And that's it. So we know that this is either going to be 1 and 6 or 2 and 3. Then we pick a pair of these that add to make 5. So 2 and 3 add to make 5. So that's what we whack in. Nice and straightforward. Always start by forming the brackets, working out what the signs are, pluses or minuses or one of each, and then list the factors of the constant term on the end. So list the factors of the 6, see what adds to make the middle one. Hopefully that's in a nice, clear way. So let's go for a similar one. X squared plus 8x plus 15. So again, we see that they're both positive. So we know that this is our favorite case because they're both going to be positives here. X plus something, X plus something. So I'll give you just 10 seconds or so to think about that. Yeah, perfect. People are getting that straight away. Well done. So again, we can list these. This is a similar one because we can only have 1 times 15 or 3 times 5. 1 and 15 don't add to make 8, but 3 and 5 do. Brilliant, well done. Okay, now on a kind of similar thought, what if we had x squared minus 8x plus 15? Now this one's different because, well, we know that our brackets, because it's just an x squared, we know that it's going to be x and x. But now the signs are going to be different. And the first thing that we notice is that the constant on the end is added. Now that means that the signs have to be the same. The reason for that is the only way that you can get a plus 15 is either by multiplying two positive numbers or two negative numbers. So if this is a positive, the signs have to be the same. And whether it's a plus or a minus is determined by this term. So they're going to have to be two negative signs. Hopefully that makes sense. Yeah, cool. Some people are already getting that on the chat. Fantastic. So it's exactly the same thing now. It's just with negative signs because they still have to add to make 8 because we're doing -3 minus 5. Perfect. Yeah, brilliant. Okay, now we'll go on to everybody's least favorite case, including mine, which is where we're going to have one of each sign. So this occurs when this term is negative, because the only way we can get a negative term by multiplying is by multiplying one positive and one negative. So we're going to set up the brackets, x and x. And we're going to do the same thing. One's got to be a plus and one's got to be a minus. Now we want to know which is which as well as what the numbers are. So here we can see 3 is 1 times 3. So we know it has to be those numbers. And if there were more options, I'll show you how to choose them in a second. More options for like what you could multiply. And now basically we have to decide whether it's going to be 3 here and -1 or -3 and 1. And the way that we know is from this. So to get -2, we do +1 -3. So I think the chat's going crazy, so I think people have got that. Yes, cool. I think most people did, and hopefully those that didn't understand where that came from now. So you always do the same thing. Set up your brackets, set up the signs, work out the factors of the constant. And if you follow this process, you should be able to do all of them. So another example like that, x squared plus 3x minus 54. This one looks a bit scarier. But we know because this is a minus, we know it has to be one of each. So we're going to have an x plus and an x minus, because that's the only way we can get a negative number is by multiplying a plus and a minus. And then we're going to list the factors, the things that multiply to make 54. So we have 1 times 54, 2 times 27. Let's make sure I don't make a silly mistake here. 3 times 8, 6 times 9. And I think that's all of them. And then what we want to do, because one minus the other is 3, we're going to pick the pair where the difference is 3. So the difference here is 53. So that's not what we want. The difference here, the difference, by the way, I mean the bigger one minus the smaller one, like the difference between them. The difference here is 25. The difference here is 5. The difference here is 3. So this is the one that we want. And now we just have to work out which way around they go. So in this case, we want a positive 3. So it's going to have to be 9 minus 6. So the 9 goes with the positive this time. So that's quite a difficult one because you have to list them all. How do you know which one is plus and which one is minus? It's whichever one works for that addition. So if this had been a minus 3x, we'd have needed plus 6 minus 9. So I hope that kind of makes sense. Whichever one, yeah, whichever one works for addition. Why 3 times 8? I don't mean 3 times 8 at all. I mean 3 times 20. What do I mean? 3 times 18, don't I? Yes, 3 times 18. That's me missing a 1. Sorry about that. Yeah, so that has a difference of 15, so it still doesn't work. Yeah, well spotted. Please do point out my mistakes. This is the first time I've done this, so I will make them. Cool. I learned that you plus the x value and then times the normal value. Yeah, exactly. So yeah, it's 2 numbers that multiply to make this and add to make this. That's exactly correct. Cool. So there are some harder ones where this is a bigger coefficient than x. But what I'm going to do is I'm going to go through solving, and then at the end I'll come back to the advanced higher level stuff. Cool. So now we're going to have a look at the whole point of this, which is solving these quadratic equations. So this is when you have a quadratic equation, but it equals something. So you actually have to find out what x is. Could you do completing the square form? If I have time, yes, because that does also come into this. So yeah, of course I can. So when we're solving, like I said, this is when it equals something, so we can actually solve for x. So this would be, for example, x squared minus 12x plus 35 equals 0. We always want it equals 0. I'll do some examples where you have to rearrange to make it equal to 0, but we always want it equal 0, and I'll explain why in a moment for you. So the first thing that we do is we factorize if we can. And like someone pointed out about completing the square, that would be good to go through, because if you can't factorize, the next best thing to do is completing the square. And then if you can't do that, the next best thing to do is quadratic formula. So we've got all of these different tools available to us, but factorizing is the nicest one. So we can factorize this. Some of you might have already spotted this is going to be x minus 7, x minus 5. So hopefully that makes sense. It's just what I was kind of explaining before. Equals 0. Now, I'll explain this both graphically and algebraically, because I know that people's brains work differently with it. Graphically, it's basically saying that the roots of this equation are here. So this would look like this. And the points that we're trying to find is where it crosses y equals 0. Like before, when I did x squared equals 9 on a graph. So we're looking to find these points here. And we factorize to find those roots. And then we do kind of need to think about the algebra of it a bit. Now, when two things multiply to equal 0, one of those things has to be 0, right? There is no way that you can think of two non-zero numbers that multiply to equal 0. So this means one of these has to be 0. And that's why the factorizing is great, because then we've got our two options. We've got that either this one equals 0, and for that to happen, x must equal 7, or this one equals 0. Equals 0. So for that to happen, x must be equal to 5. So these are going to be our points on here, 5 and 7. So if you ever get a question that's like, where does this cross the x-axis? These are called the roots of the equation, what you whack in and it makes it 0. Let me just see if there's any questions about that. 7 or 5? Yeah, brilliant. Well done, guys. Are you going to go over to completing the square? If I have time. Yeah. If not, that could always be another lesson. Do you need to present it as? I'm pretty sure either work. You can either say x equals 7, x equals 5, or x equals 5, 7. I'd probably say x equals or x equals, just to make it really nice and clear. Someone asked what the quadratic formula was. This will be drilled into your heads at some point. If I have time again, I'll go through whacking some stuff into here. But basically we express, this is quite a good thing to go through, so I'm glad someone pointed that out. Basically we express it as ax squared plus bx plus c. So a, b, and c are just numbers. This could be 2x squared minus 7x plus 1, whatever. Those are just your numbers. And then to solve this, x is, oh gosh, okay, minus b plus or minus the square root, wait, am I right? 4ac, I'm sure there's a b squared in there somewhere. Oh wait, yeah, I got it wrong, didn't I? This is why I shouldn't take questions on the spot. B squared, b minus b plus or minus the square root, b minus 4ac, b squared minus 4ac. Thanks, guys. B squared minus 4ac. I haven't had to do this formula in a very long time. I'm pretty sure that's correct now. Negative b plus or minus the square root of b squared minus 4ac over 2a. There you go. And all this means is that you take what those numbers are, you whack them in, put it in your calculator, and because of this plus or minus, you'll get two solutions. So like I said, if I have time, we'll go over that, but this is more just, this is plugging it in. So we'll go over the more thinky questions. So we'll have another go at, so for example, let's say we had x, like this, x squared minus x minus 72 equals 0. So I'll just give you guys 30 seconds or something just to, don't worry, I know I'm not giving you long, it's just to make sure that I can cover everything. So yeah, have a go at that, see if you can work out what the solution is now. There's no plus or minus button on the calculator. You'll just have to put it in once with plus, write it down, go back through, change that to a minus. Yeah, perfect. Some people are getting it already. Brilliant. So, yeah, people have put the signs slightly different ways in some of them, so I'll go through it. So this is going to factorize to x minus 9, x plus 8 equals 0. And that's because we've got a minus x here, so we want the minus 9x plus 8x. So then one of these brackets is 0, so either x equals 9 or x equals minus 8. I think that works. So some people are putting minus 9 and 8. I assume that you might be talking about the factorization. The actual solution to it is x is 9 or minus 8. The signs are the other way around because it's what x is to make that bracket 0. So hopefully that makes sense. Cool. I hope so anyway. Just because a lot of people are saying x is minus 9. Okie doke. We'll go over some slightly more complicated ones now where you have to do some rearranging, because these are the kind of ones that often throw people off because, like I said, you have to rearrange and then tackle it. So it's a couple of different skills.
Just jumping in, Molly, before we go on, should we go for another 15 minutes explaining the way you are now?
Yeah.
And then for all the people listening, there's a raise hand feature. So if you do have a specific question, what you can do is raise your hand and it will put you in a queue. And then from 1:45 to 2 o'clock, what we'll do is I'll click through as many as I can, allowing you to speak one person at a time. That way you can verbally ask your questions to Molly. So if there's anything that's come up that you would really like clarification on, raise your hand and then we can take it from there. Does that sound good, Molly?
Yeah, that sounds perfect.
Awesome.
Cool, thank you. Yeah, that means hopefully I can get through your questions. Okay, so we could have a simple case like this. X squared minus 13x equals 30. Now, remember what I said at the beginning, we want it to be 0. And the reason is because then we know that one of the brackets has to be 0. So that's perfect. So all we have to do for this one is just subtract 30 from both sides. And now we have this that we can factorize. So this will be, oh gosh, minus 10, minus 15. Difficult, factorizing on the spot, guys. X minus 15, x plus 2, I believe. Yes, that works, equals 0. So then we have x equals 15, x equals minus 2. X equals 15 or minus 2. Yeah, perfect. Well done, guys. Someone said for the previous one, what's the problem if you put minus 9 and 8? It's not the solution, basically. So minus 9 and 8 are what go into the brackets. But then the solution, if you put minus 9 into this, you wouldn't get 0. And if you put 8 into this, you wouldn't get 0. That's why the signs really matter. And yeah, with this one, just to reiterate about the graph, just in case you're asked to draw it or anything like that. What this means is that the roots, so where it crosses the x-axis, are 15 and minus 2. So 15 and minus 2. And we know that it's a positive x squared. So we can do that, which is, yeah, that's just how you draw them. Can minus 10 and minus 3 be an answer? That's what I was almost about to write, but that would make it a plus 30. So if this was equal to, if it was x squared minus 13 equals minus 30, so we rearranged to make it a plus 30, that would be the factorization. Can you explain how to draw it? Yeah, I'll go over it again with the next one, so that makes a bit more sense, hopefully. Okay, let's have another one where we've got to do some working out. Let's have a look at x. Lots of x plus 4 equals 32. So after this one, I'm going to go on to some slightly more challenging ones. So don't worry if you don't completely follow. Obviously, I can't go as slowly as I would like to. So for this is what I was talking about, doing a little bit of expanding here. So we've multiplied everything by the x. So x squared plus 4x. Hopefully you can see where I got that from. We've done x squared plus 4x equals 32. Then we want it to equal 0. So we take that 32 over to the other side. X minus 32 equals 0. So then we can factorize this, hopefully, yes, x plus 8, x minus 4 equals 0. I know I'm doing these factorizations quickly. Do just shout if you want more clarification over how I'm factorizing them. Oh, people seem to be getting it really quickly though, so well done. Cool. So then, yeah, it's x, don't know why that happened, x equals minus 8 or x equals 4. And just to explain how to draw it again, so we've got our axes here. So because our curve, this is our curve basically, y equals this. So we know it's an x squared of some form, so we know it's going to look like this, like a smiley face. That's our general shape of an x squared, no matter what you do to it. You know, whack some x's on it, whatever, but the highest term is an x squared, so it's going to look like this. And then we just have to work out whether it's kind of above or below or where it crosses. And we know now where it crosses the x-axis. Because it's where it equals 0, that means it's where it hits this line. Because we're basically saying y equals this and y equals 0, and where they intersect is where that's true. So even if you don't understand the reasoning behind that, just know that the roots are along the x-axis. So we draw on here minus 8 and 4. Obviously, this is a rough sketch. And then you do your smiley face shape through those points. So something like this. So I hope that makes a bit more sense. Why do you reverse the signs at the end? That's because we're working out what equals 0. So what I said before about when we have two things multiplied together that equal 0, at least one of them has to equal 0 itself. There's no two numbers, 2 times 2 is not, you can't make two things equal 0 by multiplying, unless one of those things is 0. So if this one is 0, then we get x is minus 8, because minus 8 plus 8 is 0. If this one is 0, we get x is 4, because 4 minus 4 is 0. So that's kind of why we reverse them. I'll do one now actually that's a bit more complicated than this, and it might actually make it make more sense. I have to see. If you have to draw the example graph, do you do it freehand? I don't know, depends what example we're drawing, depends on what the question is. Often it will just be like sketch the graph, in which case you do it freehand. Sometimes you'll have to plot the points. That really depends. But this is more about technique than actual exam questions, so that depends on the situation. Okay, got 5 minutes before questions, so I'm just going to do 2 harder worked questions. So don't worry, especially if you're on foundation, don't worry if you don't understand this bit. We will be coming on to questions again in a minute. So the first one that I want to do is x plus 3 squared minus 2x minus 1 squared equals 0. So this looks horrible, but we just follow through with our method that we do and everything will be fine. So what we want to do is expand this out and actually refactorize it, if that makes sense, so that we've just got one thing. So when something is squared, what this means is x plus 3, x plus 3. So I will go through this fairly quickly, but we'll have x squared plus 3x, so plus 6x plus 9. Hopefully you can see where that comes from. And then we'll have minus this one squared, which is 2x minus 1, 2x minus 1. So a bit trickier. 2x times 2x is going to be 4x squared. And we've got to remember that this whole thing is in brackets. So 4x squared minus 4x, because it's minus 2x, plus 1. I know I'm going quickly. As I said, don't worry. This is more for those like higher students. Yeah. And then what we do is, because this whole thing is minus, if this was a 2 here, we'd expand everything by 2. We'd factor it out. But here, this is minus, so it's like factoring everything out by minus 1. So we get minus 4x squared, and then minus 4x. So applying this minus to here. So that gives us positive 4x. And then minus 1. Combine all of these terms, so we get minus 3x squared plus 10x plus 8. So hopefully that kind of makes sense as to where that comes from. I'm just going to start this on a new page. So it was minus 3x squared plus 10x plus 8. Yes, plus 8. So this is obviously a much trickier one. Someone said, do they both equal 0? One or the other equals 0. There's 2 solutions. So just put question marks. I know that this one is confusing. It's just so that I can try to reach every level. I'm only spending a couple of minutes on this kind of thing. And then we would factorize this, which I'm now really wishing I had worked out beforehand. You're going to have a minus 3x and an x. That's how we're going to make that there. And then it's going to be minus 4 minus 2, I think. So you get minus 3x minus 2x plus 12x. Okay, so that's the factorization for that. And I know that that is horrible and disgusting. Hopefully you can see where it comes from. Like I said, this is, could you do another one, please? Another like this or another easier one? Whilst you're answering that, I'll finish this. So now we have to see, well, what makes this 0? And what makes this 0? Well, we can work that out. Minus 3x minus 2 equals 0. Take the 2 to the other side. And then divide by minus 3. So minus 2/3. Or what makes this 0? Well, this one's easier. This is more like our standard one. And this will just become, so when that equals 0, x equals 4. So here your solution is x is minus 2/3 or x is 4. That's a really difficult, like a level 8 or 9 question. This level, but a bit slower. Sure thing. Okay. Easier, another like this, please. Sure. How do you factorize when the coefficient is more than 1? Trial and error. That would kind of take me a whole, like a bit more time than I have. But essentially, I did the same thing in my head. So I knew that this had to be in fact, it's difficult because there's that minus as well. Basically, I knew that this had to be a 3x and an x to make that x squared. I tried different values of this. So 1 and 8 and 2 and 4. Tried putting them in. I knew it had to be minus and minus because one would go with this. This is a really hard example. I'll do one like this, but a bit slower and slightly, hopefully slightly easier to do. And then we can go on to questions. So let me do, okay, let me do this one for you. 2x minus 5, x plus 1 equals minus 12x. So I'm going to rush through the expansion and stuff so that we can focus on the factorization and have time for questions. So 2x squared minus 5x plus 2x minus 5. So that's 2x squared minus 5x plus 2x minus 5 equals minus 12x. And then we whack everything on the left-hand side so that it equals 0. 2x squared minus 17x. Oh, sorry. We've got to add the 12x. So it's plus 7x. Yes. And then plus that 2x. So that's actually a plus 9x minus 5 equals 0. So I think that should be the expansion. Now, obviously, we've done a lot of steps in one go. Is there a method where you times the coefficient with the last number? Yeah, kind of. So it's, yeah, I'll show you with this one. So now we've got something that equals 0. We've done that expansion. We can do this. We set up the brackets with a 2x and an x. This makes the 2x squared term. Then we look at our signs in exactly the same way. Well, this is minus. So one has to be plus and one has to be minus.
Hey, Molly.
Hiya.
Sorry to interrupt. So what we're going to try and do now is, I thought it'd be a good chance to try and answer some of the questions from the attendees. So we have a few people that have raised their hands. So I can see that we have a question from Cynthia. So Cynthia, what I'm going to do is I'm going to allow you to speak, which means that you can pose your question. So if we give it a shot and see what happens, if it doesn't work, then we can always move back to answering questions via the chat. But just thought we'd give it a try.
Sure.
Okay, so Esther. Okay, it doesn't look like that's working. Oh, it was working. Hi Esther, how are you?
Hi, I'm good. How are you?
Good. Did you have a question for Molly?
Yes. So for the previous question,
This one?
where it's minus 3x, minus 3x equals 2. So you see when you do x equals minus 2 over 3, wouldn't that be positive because the sign changes on the other side?
So minus 3x equals 2. I'm just going to put this on a new tab to show you here. So it's just the step here, minus 3x equals 2, wasn't it? Minus 3x equals 2. So no, if this was a minus 2, they would cancel out. But what we're effectively doing here is just dividing straight away by that minus 3. So 2 over minus 3. And then because that's a negative fraction, I'm just putting the minus on the top. That's just convention. So this is the same as minus 2 over 3. Does that make sense?
I think she's off unmute now. Should we try another question from
go for it.
Aisha? Hi Aisha, did you have a question? Okay, doesn't look like we have Aisha. Should we just carry on then, Molly?
Yeah, do you want me to just continue?
Yeah,
cool.
Why not?
Keep asking questions in the chat. Most of them I can make sense of. Can you finish the last question? Yeah, I'll go back and finish the one that I was doing and then just shoot me any more questions. So this one. Cool. So I'll just remind you of where we got up to with it. So yeah, factorizing with a larger coefficient. Yeah, so we've done 2x and x. Hopefully you understand why I've done that. That's to make our x squared term. And I was just saying that because this is a minus 5, we know our signs are going to be plus and minus. But we don't know whether it's the plus here or the plus here. So it's a bit tricky. We can't put in our sign straight away, which is what we like to do. But we're going to just continue doing it the same way that we would. So we'll think about what multiplies to make 5, which, lucky for us, is just 1 and 5. So we know our numbers. We know that our numbers are 1 and 5, and our signs are plus and minus. So we've got a few options that we can try. For example, we could just whack them in, try a plus 5 and a minus 1. You know, we can try whatever we want. What I would say is that you can kind of be smart about which options you try first. The key thing to remember is that whatever we put here will end up being multiplied by the 2x. Now, we want, oh, cool, a poll, nice. So answer that for what you want next week. We can be smart about what we put in. So because we want a plus 9x, we know that we're going to have something quite big. You know, if we had the plus 5 here, then whether we add or minus the 1, it's only an add or minus 2, so it's not going to work. So I'm just going to see in the chat, see if anybody's got it. You have to multiply 2 by 5. Perfect. Yeah, brilliant. We want to multiply the 2 by the 5 and make that positive so that we've got the plus 10. So yeah, we're going to put the 5 in there because that means that when we do our FOIL method, our outer is going to give us 2x times 5, so plus 10x. And then that means that we put the other sign and the other number in here. And we'll just check that that works. So we get 2x squared plus 10x minus x. Perfect, that makes 9x. And then minus 1 times 5 gives us our minus 5. So hopefully that makes sense. So then our solutions to this, well, when this one is 0, we're going to get 2x minus 1 equals 0. 2x equals 1, so x equals a half. And when this one equals 0, we get x equals minus 5. So as a couple of you rightly worked out, well done, x is either minus 5 or x is a half. So hopefully that makes sense. Someone said, will these lessons be on every day? I don't know. That's a question that Frederica can answer maybe at the end. So yeah, hopefully that one makes sense. So there's a couple more things that I can do. So I'll just kind of let people ask on the chat. I can either do some more hard questions like this. I've got one where you have to form the equation yourself, or I can start to cover completing the square. Just shout on the chat what people want to do. Hard one. Anything. Square. Oh my gosh, this is very 50-50.
Hey Molly, how about we do a harder question just to stay on topic, and then next time we can think about completing the square.
Sure, yeah, good plan. Yeah, because completing the square I can talk quite a lot about. So I can talk about completing the square in terms of solving quadratic equations, but there's a lot more that we can do with it. So yeah, Frederica's got a point. We'll do that in a separate one. So let me just grab for you this harder question here. Can I get back to this tab? Yes, I can. So I'll paste it on here so that we can see it and draw on it. So this is this would maybe come near the end of an exam. This is a hard question, but quite cool because you get to show off loads of different skills. So we've got a trapezium here, and we've got the lengths of the sides in terms of x. So x plus 6, x plus 2, and x minus 5. And the area is 36. So they're all in centimetres, so we can just talk about them in terms of numbers. We can just talk about them in terms of numbers, yeah. So what we're going to have to do is form our own quadratic equation from this, from the information that we know. So does anyone know how you find the area of a trapezium? Don't worry if you don't, I can go through it. Half a plus b times 8, perfect, yeah, well done. We always used to do a little rhyme for it, which I won't subject you to now, but yes, half the sum of the parallel sides times the distance between them. That's how I always learnt it, little thing, so perfect. So if we write that out, so the sum of the parallel sides is x plus 2 plus x plus 6, which is going to be, we add the x's, we add the numbers, 2x plus 8. And then as the one rightly said, we want half of that. So half of 2x plus 8, we just halve both elements of it. So we get x plus 4. Great. Now we want to do times that by the height. So the difference between them. That's the line there. I'm going to have to make it quite small to be able to write. Hopefully you can still see the question. So this, and then times that by h, the height, which is here. So that's going to be x plus 4 times x minus 5. And then to make it an equation, we have to equate it to something. So we know that that's the area, which we're told here is 36. So we formed an equation there, which looks quite familiar as what we know. Someone says, can you do that? Okay, I'll do the rhyme. I think it's to the tune of Pop Goes the Weasel. So bear in mind with my beautiful singing voice. So half the sum of the parallel sides times the distance between them. Follow these rules and you will find the area of a trapezium. There you go. Hold the praise. That's how I learned it. Wow is the correct response. Hopefully that helps and I didn't just sing for no reason.
That was beautiful, Molly. Thank you,
Frederica.
That's okay. I really liked it.
That I honestly still remember that now. I'm sat there in my uni lectures singing that to myself. Maybe I will go on X Factor. Thanks, guys. Anyway, back to the question. So we've set this up with my beautiful rhyme, and because it's the area, we've set it equal to 36. And now we have something that looks much more like what we were doing before, which we can now solve. So the first thing that we want to do is expand this out, because remember, we want it to equal 0. So we're going to expand it out, take off the 36 and refactorize it. So using our FOIL method, we get x squared plus 4x minus 5x, which is minus x, minus 20, that's a 4 times minus 5, careful with the sneaky minus, equals 36. Then we're going to take that 36 over to the other side, so subtract it. So we get x squared minus x minus 56 equals 0. And now we factorize this. Because it's a minus, we know it's going to be a plus and a minus. Luckily, we now only have a coefficient of 1, so we don't have to worry about that. Can anybody see how this factorizes? Do we have to work out the area when it was already given? No, we're basically working out the area in terms of x and setting it equal to the area that was given, so that we can minus 8 and 7. Yes, perfect. Well done. That's because 8 times 7 is 56. And to get the minus x, we want to subtract the bigger one. So minus 8x plus 7x gives you minus x. So then, what is x? This question doesn't actually, what I've pasted doesn't have the question. The question is basically find x. So then, what could x be? It says it. So there's a little bit more of a trick to this as well. So I'll show you. So we know that our options for x are going to be x equals minus 7, x equals 8. Can anyone see an issue with either of those answers? How much time is left? Literally 3 minutes.
Hey Molly, I was just going to jump in and say that maybe it might be a good point to just stop and just for me to answer a few of the questions that have come through from other people.
Yeah, sure. Okay? Can I just say one more thing about this so that I don't...
Go for it.
It's just, all I was going to mention was that if you do choose x equals minus 7, then the side lengths end up being negative, which we can't have. So the only acceptable answer here is x equals 8. So it's just a comment about sometimes, depending on the question, you have to check both your answers. Yeah, that's me done.
Cool. Thank you so much. That was amazing. Just to explain or answer a few of the questions that people have sent through. So lots of questions were around how often our lessons going to be and what subject level or what subjects we're going to have MyTutor. So I've sent a link to a survey through. If you take part in that survey, then you can help us figure out what specific subjects you want and also what other lessons you want to see in other topics, other subjects. Just to say that for now, we're hoping to have another webinar tomorrow, which will share details for as and when. So the more of you that can get involved with the survey, the better, because we really want to make sure that we're catering to what everyone wants and helping you guys get the best out of your time. So that's everything from me, and hopefully we can work together to get the best sessions for you through the survey. Molly, do you have anything you want to add?
No, just thank you all for being interactive and asking questions. Hopefully that was helpful.
Cool. Thanks everyone. So yeah, watch this space for more information about the webinar that's going to be coming tomorrow. The final thing to add is that this webinar has been recorded and so it will be shared with you and you'll be able to access a load of other resources that we have in the pipeline as well. Thanks everyone. Have a lovely day.